Okay, good morning everyone. So in this lesson we're going to talk about an ellipse, okay, which is the third shape we're going to be doing so far. And then with it, after doing this ellipse, we'll only remain with a hyperbola, then we'll be done. So what exactly is an ellipse? Okay, so it looks, that a circle, okay, ideally a circle looks like this, okay. An ellipse, however, looks something like this. Okay, it's somewhat oval, not necessarily round. So as you may see, because an ellipse does not necessarily have even distributed sides rather. Okay, this is the longest, as we may see, and this is the shortest distance from one end to another. So this here, this whole thing, is the major axis in this case. Okay, it's the major axis. Then this is the minor axis. So if the conic section, which is the same hyperbola, is oriented like so, sorry, the same ellipse is oriented like so, then this here is your minor axis, and then this, sorry, this here is your major axis. So remember what we discussed last time regarding a parabola. Okay, I had to ask a question: where exactly is the foci or focus? It is located at some point P, starting from the vertex here, going up at some point P. So in a similar way, this here is your ellipse. Okay, where then would the focus be located? Let me just draw it nicely. Let's see. So where exactly would your focus be located? Starting from the origin here, not the vertex here, no. Starting from the origin, would move at some point positive C. And then in a similar way, so this is where the focus will be. In a similar way, we do the same on the other side. So if this distance is 5, then we'll also move 5 units towards the negative side. So this will be -5. That's where that focus would be. Remember, this time we're starting from the origin, not necessarily from the vertex. The vertex in this case is here, and here, and here. So now, another thing, so this here is -C. Another thing we need to take note of is this. Okay, so this here is -5, or yeah, so it's just -C, okay, in the x-axis. So another thing we need to take note of is this. Okay, the distance from the origin, which is here, to the focus is C, but the distance from the origin all the way up to the vertex is called A. Okay, let's call that A. So meaning from here up to here, it's also A, since the distances are the same, going either direction, to the right or to the left. So this is your ellipse, major axis, minor axis, and then your focus. So this here is your C, this here is your C, meaning if this from here to here it is A, and from here to here it is also A, then the entire distance from here all the way up to here is 2A. So this is A, this is A. So some of the properties of this ellipse is this. Remember, just as we were talking about regarding a parabola, okay, we said excuse me, we said that the distance from here up to here, up to all the way down, this here is the, hold on, this here is the directrix. We said the distance from here to here is the same as the distance from here to here. Then we had to equate them, and then we solved everything else. So using the same logic, but this time it's different, okay? Here's the thing. Should you draw a line, okay? Should you draw a line from one focus to the surface, to any part of the surface of the ellipse, and then back to the other one? This entire distance here is the same as the distance from here to here, which is just 2a. Yeah, so the distance from here to here all the way up to here is the same as this whole distance. So if this were to have different coordinates, okay, if we were to start from here and then maybe hit this other side and then come here, okay, still this whole distance here would still be equal to the distance from here all the way up to here, which is what? 2a. So to make things simple, let's actually let's give this some values, okay? So let's start from here and then we reach the surface. So this surface, since as we may see, it's on the x-axis, so it's on the xy plane, okay? This point here, it is on the xy plane. So let's give it its coordinates. So the coordinates for this would be x, comma, y. The coordinates of this focus here, this is negative c by the way, would be negative c, comma, 0. That is x, comma, y. So it's some point c and then 0 in the y, okay? Then the coordinates for this one right here would be c, comma, 0, because it is moving some point c in the x-axis and then 0 in the y, since it's not moving up or down. So let us write down our distance equations. Remember, just a recap of what we did last time. If you have a point here, rather, this here is your xy axis, xy plane rather. And then you've got some point here, and then you've got some other point here. These are the points we're interested in. So this point is located somewhere, we don't know where, okay? Somewhere x, comma, y. This is also located somewhere x, comma, y. So there's a distance between them, as we may obviously see. So this distance can either be d or r, whatever it is you put there. Let's just go for d, since it's obvious that way. So to find the distance between these two, again we just write down the distance equation, which is d is equals to, we do this, we open the square root, and then we say, let's call this 2 and 1, since it is greater in the x-axis. This here might be 5, then this here might be 4. Then in the y, this here might be 1, and then this here might be 8. Who knows? But all that we know is that the ones here at the top are greater than these. So these will be 2, and then these will be 1. So x1, y1, x2, y2. So it will be x2 minus x1, close bracket, squared, plus, open brackets, y2 minus y1, close, squared. So we're done. This is a distance equation, okay? This is point F, and then maybe this here is point P, just randomly, okay? So meaning this, let's replace this D with just FP, okay? Or PF. So FP, okay? So that is the distance equation for this. So using the same knowledge, let's find the entire distance equation and equate it to 2a, okay? Because like I've said, the distance from here up to here is the same as from distance from here to here to here is the same as the entire distance here, which is 2a. So let's give it some names, okay? This ellipse right here and these points. So let's call this point f1, let's call this f2, and then let's call the top part f let's call it p, okay? Let's call it point p, so that we say the distance from f1 to p plus the distance of f2 to p, or let me just say from p to f2 should be equal to 2a. So now let's find the distance f1p, which is this distance here, by using the same knowledge which we're just talking about right now. So that would be, we do the distance equation. Okay, so this would be, now let's get their coordinates. Let's remember we're talking about f1 and p. So the coordinates of f1 are -c, 0. This is f1, and then the coordinates for p, it is just x, y. So this is what we're going to use, x2 and y1. That's what we're going to use, because it's lying in the surface of this ellipse. Okay, so this would be the case. So it will be x2 minus x1, which is minus -c, close bracket, squared, plus y2 minus y1. Okay, so we've written down our distance equation for f1 and p, which is just simply for these two. Now let's find for this as well, which is this pf2. So we say plus pf2. Okay, what are the coordinates of point p? Point p, it is just x, 1, y. It's the same one. Then point f2, which is this point here, would be c, 0. Okay, yeah. So now we say plus, we open brackets, we say x2 minus x1. What is our x1 in this case? It's just a c, squared, plus y2. What is our y2 in this case? It's just y, minus y1. What is y1 in this case? It's just 0. Okay, here it is c, 0. So the y here, the y1 is 0. So this is what we have. Should be equal to what? 2a. So this thing which we've written down here, this whole thing, is just a distance equation of what? Of this whole thing, from one focus to the surface of the ellipse, and then to the other focus. Okay, so let's simplify. So let's start by taking this here, okay, to the other side, or rather adding both sides. I believe you know what that means, but yeah, let's just make it simple by saying we throw it to the other side. So let's first simplify this here. So this will be x plus c, because negative times negative is positive, plus y2 minus y1, plus, let's simplify this. So this here will just be a, sorry, and yeah, x2 minus c squared plus excuse me, plus y squared, we want to put a square there, is equals to 2a. Okay, now let's take this to the other side. And by the way, this x here is the same as this x here, so it's not really necessary to indicate the 2 here, but I was just doing it to show that, okay, we're dealing with x2, so it's necessary to put the subscript 2 there if you have two values of x. So assuming this was also x here, it would be necessary to say x2 minus x, but in this case it's just not necessary to even put a 2 here, because it's obvious that we're dealing with x2 minus c. So let's move this to the other side. So this will now be x plus c squared plus y2 minus y1. Wait, hold up, I've made a mistake. Yeah, so this here is a formula, this here is the correct formula. Yeah, x2 minus x1, y2 minus y1, but in this case our y1 here was 0. Okay, and our x1 was negative c. So these are what we have: y2, y1, x2, x1. So where there's y1, we should have put a 0. So this here is a 0. So this as well is a 0. Let me just rub that out. So let's see. Oh, this as well. Yeah. So this here is minus 0. And then all that we're going to remain with here is just y squared, since we can say y, y squared, because there's a square here. So plus 0 squared, which of course will just be y squared. It's the same thing. Yeah, so the error has been corrected. So that is supposed to be our y1 was supposed to be 0. So moving on. So this is pretty much unnecessary to write. We can just write it down as x plus c squared. Then we say plus, and then we say y squared. Remember, this subscript 2 is just to indicate saying we're dealing with a different y, but here it's a 0. Okay, unless if we had a y, it would be necessary to write down y2 then minus y. Okay, but it's pretty unnecessary because all that we have is just one y, which is the same everywhere. So that's a minus there. So this plus x minus c squared plus y squared should be equal to what? 2a. Okay, so now let us take this to the other side. Let's make it jump, in quotation marks of course. So this would be x plus c squared plus y squared should be equal to 2a minus the square root of x minus c squared plus y squared. Okay, now let us now take the square root of both sides, because I want to get rid of these square roots. So we'll say we open brackets here, we open brackets there, then we do the same starting from here all the way up to here. Then we say 2 raised to the power 2. So this goes, that goes. Then what were, by the way, then so this goes, that goes. Then here, do not make the mistake of saying no, this goes, that goes, excuse me, and then these two cutters for this. No. Think of this as a minus b squared. Okay, where when evaluating this, it is the same as a minus b times a minus b. Then we just use the same rule of saying a times a, which would be a squared, and then we say a times negative b, it will be negative ab. Then we say negative b times a, it is then the same as negative ab. And then negative b times negative b, it will be positive b squared. So using the same logic, let us deal with this. Okay, so take this entire thing here, okay, as your a, and then take this whole thing as your b, okay. So let's deal with this first, and then we'll say is equals to this. We'll deal with that later. So let's deal with that first. So this here is 2a, and then it is minus it is 2a, and it is minus x minus c squared plus y squared. Okay, so this whole thing is in square roots, so it is the same as writing it down as 2a minus the square root of x minus c squared plus y squared, close. Then we say the same thing, 2a minus x minus c squared plus y squared. So having done this, So having done this, we can now start multiplying just as we did like on when illustrating between A and B. So take this whole thing as your A and then this as your B. A, B. So this times this, it is going to be 4A squared. Okay, then the same 2A times this whole thing here, including the negative, is going to be negative 2A, open brackets, everything that is in the brackets. So that's going to be x minus c squared plus y squared. Okay, so we now move on to this times 2A, which is just going to be negative 2A, open brackets, and then everything inside, of course, which is just the same. So it is going to be x minus c squared plus y squared. Okay, then we say this whole thing times this whole thing, including the negatives. Okay, so it is going to be negative times negative, here this negative times this negative, which will of course give us a positive. So it's going to be plus, then this same thing times this. Okay, now before I multiply, think of this as 2, the square root of 2 times the square root of 2. Okay, this is going to be the square root of 2 squared. So this will go, this will go, it is just going to be 2, which is just what is in the inside. So using the same idea, multiplying this times this will only give us what is inside. So it's going to be plus, since negative times negative is positive, it's going to be plus x minus c squared plus y squared. Then because you multiplied them, it is going to be 2. Then we can just cancel this out and cancel this out. So we've only remained with what's inside. That's all that we need to write there. So, okay, that's a long equation we've got there. So now, remember, we're just dealing with what? What were we dealing with? This here, okay? This here, that's what we're dealing with. So let's simplify this and then we should equate it to this. Because remember, this here is towards this side, okay? It is somewhere this side. Let's just try to simplify. That's why I had to forget about it for a moment. So as we may see, this, when we have negative 2 minus 2, it is just the same as negative what? Negative 4. So in a similar way, this here, this whole thing is the same. Rather, this is the same as this, okay? So that is going to be 4a squared. Let me just zoom in a little bit. 4a squared minus 4a raised to the, 4a square root x minus c squared plus y squared. Then at the end we say plus, we write down everything this side, which is just going to be x minus c squared plus y squared. Okay, yeah, then should be equal to this, which we had forgotten about for a moment, which is this here. So that is x plus c squared plus, what are we having? Y squared. So now let's simplify even further. Okay, so what is common on both sides? Excuse me, on both sides. So as we may obviously see, y is common, so we can simply cancel that out. So this goes, that goes. Okay, now let's expand what we have. Let's expand this, let's expand that. Okay, so when we expand what's on the left, we're going to have x squared plus 2xc plus c squared. So just as we discussed last time, in order for you to simply expand this without having to write them down here, you write down one, you close, you also write down the other here. You just say the first one squared, then you multiply these two together, you're going to have xc. Then you just add the 2 at the front, okay? Then plus c squared. So x squared first, you multiply these two together, then you add the 2 at the front, excuse me, and then as for the last, you just say squared. So as we may see, this here is a positive. If there was a negative here, would add a negative here, but a positive here. So should be equal to 4a squared minus 4a, and then we say the square root of x minus c squared plus y squared plus, when we expand this, what we're going to have is this. We'll have x squared minus 2xc. Remember, multiply these two together, then add the 2 at the front. Then as for the last one, it's a plus c squared. So as we may see, this has a negative at the front, so that's why we have a negative firstly, but at the end it's always a positive. So let's cancel things out again. So what do we have that is common on both sides? So the x is common, x squared is common, the x squared is common there, so we've removed that. What else is common here? Okay, the c squared is common, the c squared is common. Okay, so what we're remaining with now is 2xc. Let me just write that again. So now what we're remaining with is 2. Let me just increase this. Okay, so what we're remaining with now is 2xc. 2xc is equals to 4a squared minus 4a, open brackets. Sorry, we do that. X minus c squared plus y squared minus 2xc. So we can't cancel this with this, because as we may see, they're not the same. One has a positive, one has a negative. So let's take everything else, everything except from this, to the other side. So let's start with this. When you take it to the other side, it is going to be 2xc plus 2xc. Okay, should be equal to, this here is 4a squared. Oh, we're taking that as well. So we're taking it to the other side. When we do it, is going to be, when it goes to the other side, is going to be minus 4a squared should be equal to negative 4a. We do that, then this here will be x minus c squared plus y squared. So this is just going to be 4xc minus 4a squared should be equal to negative 4a square root x minus c squared plus y squared. Now we want to have so yeah, what we can now do here is factor out the 4 this side, okay, so that we should cancel out with this. So this will be 4, then this will be xc minus a squared, we close, excuse me, should be equal to negative 4a. We just write down nicely. Okay, so it should be equal to x minus c squared plus y squared. So this 4 goes with this, and what we're going to remain this with this side is going to be x c minus a squared, we close brackets, is equals to parenthesis, negative a square root of
x minus c squared plus y squared. So I want to get rid of this negative this side. So we're going to multiply both sides by a negative. I want to get rid of this negative. So when we do, this is just going to be positive. Then this here will be a negative. Then this will be excuse me, a positive. Okay, which is what we've been looking for. Okay, so now what we want to do is to get rid of this square root. Okay, we want to get rid of that. So not square, yeah, this here. We want to get rid of that. So we'll do so by saying raised to the power 2 to the power 2 on both sides. So we say we do this, then we say raised to the second power. We do that as well. Then we say raised to the second power. So with this, as you may see, with this, there is no positive or negative at the top. So what we're doing there of a minus b squared does not apply. Okay. So what we're going to do here instead, and it only applies here since there's a positive here. So what we're going to do here instead is this. Okay. This here will be x squared. Then this square root will get cancelled out, of course. So this will be open brackets. The square root has been cancelled out because of these two there at the top. So we're now going to have x minus c squared plus y squared close. Okay. Then this side, that's where what we talked about actually applies, just as we did with a and b. So the first one is going to be negative. So we're talking about it being squared, so it's not going to be negative, it is going to change to a positive. So it will be the first one squared, which is this, but it is negative, okay, which is negative xc times negative xc, which just be a positive x squared c squared. Okay, then as we may see, we now multiply the first and the second, then we say times what? Times 2. But one of them has a negative, so now what we're going to have is negative what? 2xc a squared. Let me just write that down again to avoid misusing space. So let me even try increasing the, yeah. So it is going to be x squared c squared, then we say minus 2xc a squared. Then we go for the last one, so we say plus the last one squared, but as we may see, it already has a squared at the top, so it is going to be a to the fourth. Okay, because that is a 2 there, then times another 2, of course, which will be a 4. Okay, now let's deal with the left side, sorry, the right side excuse me, and expand what's inside there. Okay, so this here, just rewriting it, let me not write it, it's a waste of time. This here, it will come here. Okay, I'll write it down nicely. Let's focus on the left, on the right rather. So this will be a squared, we open brackets, and let's do with what's inside first. So this, when expanded, will be x squared plus 2, sorry, minus 2xc plus c squared. We close. Okay, sorry, we do that, and we say plus y squared, and then we close. Then should we multiply everything? Yeah, then we're still dealing with this. Let's simplify it even further. So what we're now going to have here is, when we multiply everything inside by a, so this here will be a squared x squared minus a squared, rather 2a squared xc, which is this. Then we say plus a squared c squared plus y squared. Now let's just equate it to everything at the top. So on the left. So this would be x squared c squared minus 2x ca squared plus a raised to the fourth. Okay, so I can't even zoom out. Okay. let me try minimizing things here. Let's see if I can minimize. Okay. Okay. So I can actually do that. So let's minimize this as well because I'm failing to zoom out. Let's take it somewhere here. So yeah, so this here is what we have. Okay. Oh, by the way, this y, this a also multiplied with this y. Okay. So this here will be a y squared. Sorry, a squared as well. So the a needs to be there as well. So a squared. So having done this, we can now cancel out what's common on either side. Now, please do not memorize this. Just ensure that, okay, you multiply what you have to multiply, you look at it nicely. Once you reach at a point where it looks so linear as it does right now, you try to look at what you can cancel out. Okay? So, in this case, this here is the same as this here. Okay? They both have negatives. So this will go, and then this whole thing as well will go. Okay, so what we're going to remain with on the left side will be x squared c squared plus a raised to the fourth should be equal to what's on the right, which is going to be a squared x squared, what else, that is plus a squared c squared plus a squared y squared. Now let's do this. Let's take everything that has x and y to the right. Okay, everything that has x and y to the right, let's take it. So this will be x squared, this will remain where it is, c squared. Then we say, let's see what has an x. This has an x, so it will go to the other side. So when we take it this side, what we're going to have is minus a squared x squared. Okay, should be equal to oh, hold on, before we do, this here has a y, so we take this as well to the other side. So minus x squared y squared, when we take it, it will change the sign. I know we don't take it to the other side, neither does it jump. All you have to do is just add both sides or subtract both sides. That is the correct way of saying it. But for the sake of everyone and covering everyone's IQ, we say it jumps. So what remains to the other side? This remains, and then this has to go this side. Okay, so let's start with what remains. So that would be a squared c squared. Then we take this to the other side. It is now going to be minus a raised to the fourth. Here, we need to factor out the x. Okay, here, hold on. Yeah, here. Okay, so when we factor out the x, we have x squared. So hold on. When we factor out the x, we have x squared. We open brackets. Then thing is, we're going to remain with c squared minus a squared, but that's not what we want. We want the a to be positive. So meaning as we factor out together with the negative, excuse me, the negative, so that this becomes negative c squared plus a squared. When we rewrite this, it is going to be a squared minus c squared. We close. And then we say minus, there's a y here, minus a squared y squared should be equal to, we do the same thing here. So what is common here, okay, between these two, this and this? It is a squared. So when we factor out a squared with open brackets, again, we don't want a to have a negative. Okay, we don't want a to have a negative. So as we factor out, we are also factoring out the negative, the minus. Okay, so when we do so, this will then be negative c, since this negative times negative will give us this positive c. Okay, and then this negative times positive will give us this negative a. So it will be plus a squared. Okay, c squared. But again, let's just rewrite this so that it should look neat. So it is going to be a squared minus c squared. We close. Okay, then what we now do here is this. We want to have this side of the equation to be 1. So what do we now do? We divide by, sorry about that, we divide by a squared minus c squared. We close. We do the same thing here. This will be a squared minus c squared. We close. Then we do the same thing here. This will be a squared minus c squared. We close. So when we cancel this out, in fact, let's include the a. Okay, let's include the a. The minus a. Okay, minus a, minus a. So that when this goes, this goes, this goes, this goes, and what we're going to have here is a 1. We write down, we will write that down nicely at the bottom there. So this a squared is a squared, by the way, squared there. So this a squared will go, this a squared will go, this minus will go, this minus will go. We are going to remain with a plus. And then this minus will go as well, this minus will go. And then this goes again, that goes again. So what we're going to have here, let's start with this part. So we're going to have is x squared over a squared, okay, plus, what do we have here? The remaining thing here is y squared over a squared minus c squared. We close. Should be, no, this doesn't look neat. This doesn't look neat. Let me just zoom in a little. Of c squared, then we close. Then this side we're going to have a 1. Okay, you should always strive to have a 1 whenever you're dealing with an ellipse. So now what you're going to do here is, what do we have? Yeah, so this here is the final equation. This here is the answer. This here is the equation of an ellipse. Okay, but it is not the final equation. Now let me just explain. Okay, you know how that with a quadratic equation you have a squared is equals to b squared plus c squared. So this here is a squared minus c squared, isn't it? So let's write down this equation to fit, to fit a squared minus c squared. So now what we're going to have is a squared, then this c goes to the other side. It will be a minus c squared is equals to what? B squared. So this a squared minus c squared is also this a squared minus c squared, which is equal to b squared. So we can just replace this with b squared. So finally, our final equation of an ellipse is going to be x squared over a squared is equals to plus y squared over b squared should be equal to a. Then we're done. This is our final equation. Now here's the thing. A is always the major axis, the major axis. B is always the minor axis. If you'd like to prove, you can use the same procedure, but this time don't use this. Use this. Your equation won't look like this. It will change. What will your equation look like? It will look like this. So this is for an ellipse whose major axis, whose A or major axis is what? Is X, and the minor axis is B. So if it were to change, okay, it would be x squared. If it would be like so, it would be x squared over b squared plus y squared over over a squared is equals to 1. So let us just carry on and look at some examples. Okay, so please remember what we discussed earlier. From here to here, this is a. Then from here all the way to here, this is negative a. Then the whole distance is 2a. Okay, then of course it's because this here is the major axis, then this here is a minor axis, so meaning this here is negative b. From here to here it is negative b, and then from here to here it is positive b. Okay, so let us look at this question. We've derived the equation and we figured out that it is x squared over a squared plus y squared over b squared should be equal to what? 1. Here's the thing. So here's the question. Find the vertices and foci of the ellipses. Okay, this must be a mistake. Okay, yeah, this is actually correct. Since there are two. Find the focuses and find the vertices and foci of the ellipses given by the equation x squared over 25 plus y squared over 49 should be equal to what? 1. So they're telling us, saying it is x squared over 25 plus y squared over what? 49 should be equal to what? 1. So now I want you to take a close look at this. Our equation tells us, saying that from here to here, this here is a, then from here to here it is b. That's if this is the equation. Okay, but if the graph comes like this, our equation will change. It will be x squared over, okay, sorry about that, to be x squared over b squared, okay, plus y squared over a squared. Why is this the case? Because y is now the major axis. The major axis is now in the y axis, and that is why we're taking this as our a. So it is actually a squared in our equation, and then this here is also b squared, but this here is 25 and this here is 49. So what we can now do here is this. It is going to be x squared over what is it that would let's simplify this to in a way that if we square it, it is going to give us 25. So our answer here is going to be 5 squared plus y squared over, we do the same thing here, because again, according to our equation is suggesting, saying that this here at the bottom, okay, and this as well at the bottom is going to be raised to the power 2. But you shouldn't just add it 2 here and there. It is going to be wrong. We need to maintain what we have, but write it in a way that is going to give us an equation. So not an equation, a squared and a 1 here. Okay, so here what are we going to have? It is 7 squared. So now when we look at these two, okay, this and this, which one is bigger than the other? Is it 5 or 7? So obviously it is 7. So for that reason, 7 is A and 5 is B. Meaning the major axis is in the y-axis and the minor axis is in the x-axis. So our ellipse will look something like this. Something like this. So meaning when you count from the origin all the way up, it is going to be 7. And when you count from the origin all the way down, it is also going to be 7. Then when you count from the origin to your right, it is going to be 5. And then from here to there, it is going to be a 5. that is our ellipse right there. Okay, they've told us to find the vertices and foci of the ellipse. So the vertices, this here is the vertex, this is also the vertex. Okay, so the vertices will now be 0 for x, 7 for y, and 0 for x, comma, -7 for y. These are the vertices, this and this. So these are vertices, quite alright, but these are for the major vertices. Okay, then the minor vertices, okay, are this and this. So the minor vertices will now be +5, that is for x comma y, +5 comma 0, and -5 comma 0. We close. So these two, this one and this one, are the minor vertices. Then this and this, those are the major vertices. Now the foci, how do we find that? Because there's one here and another one here. How are we going to locate that? So to find where the foci is, remember we said the foci is what is C. So from the vertex to here, that is C. Sorry, from the origin to here, that is C, and from the origin up to here, that is negative what? Negative C. And we know, saying that A squared is equals to what? B squared plus C squared. Let us now solve for C, because that C right there is where that foci is. So it is going to be C squared is equals to C squared. Okay, I'm having some technical challenges. C squared is equals to, okay, my pen's running out of battery. Okay, so this here will be C squared is equals to, okay, so I'll continue later onwards because okay, so this will be C squared is equals to A squared minus B squared. Now what is our A? We know what our A is. Our A is a 7. So that would be 7 squared, which is 49. So this is going to be 49. Let me just take that there. So I have 49 minus, what is our B? We figured out that our B is what? 25. Okay, because it is smaller. Then C is where the focus is. So we take the square root here, we take the square root there. So we cancel that out, What are now going to remain with here is C squared is equals to what? What is 49 minus 25? Our answer is 24. So this would be the square root of 24. Okay. Oh, this goes as well because it goes out, cancels out with this. So C is equals to 24. Okay, the square root of 24, which when you use my advanced calculators, you can tell that it is the same as this, or even just complex numbers. Okay, so that is our C, and that C is our foci. Okay, we're told to find what? Find the vertices and foci of the ellipse. So that's all that we're looking for. So this foci, this is positive, as we may see, meaning it is from, let me just draw another one here. Our ellipse looks something like this. This is the minor axis, this here is the major axis. From here to here it is 5, from here to here it is -5, from here to here it is -7, from here to here it is positive what? Positive 7. Okay, then our foci is the C. So this from here to here, that is A, from here to here, that is A, from here to here, that is B, from here to here, that is what? Negative B. Then our C is negative C here, and the end positive C. That is our C. which is the root of what? 24. The same goes here, the root of 24. That is our C. Yeah, so we found everything that we're looking for. Let's solve the other question. Okay, the other question is telling us, okay, this is the case. 6, let me zoom in a little bit. 6x, okay, so yeah, my pen is dying out. 6x squared. Okay, let me just have it charged and we'll carry on from there.